The objective of this lesson is to identify the greatest common factor of two given numbers in the range of 1 through 100. Students' last exposure to factors was in the 4th grade Operations and Algebraic Thinking strand. To review, a factor is one of two whole numbers when multiplied together produces a product. Students often confuse factors and multiples. Remind them that there are few factors for each number, but many multiples. Although there are many ways to find the greatest common factor of two numbers, we will list and compare the factors. This allows students to focus on and practice their number fact skills. How many factors can you find for the number 24? Let's try building rectangular arrays for 24. To describe this array, the number of rows or groups is the first factor, and the number of columns or things in each group is the second factor in a multiplication expression. This array has one row with 24 in each row, so 1 and 24 are factors of 24 because 1 times 24 equals 24. To describe this array, there are two rows with 12 in each row, so both 2 and 12 are factors of 24. How would you describe this array? It looks like 3 rows with 8 in each row, and 3 times 8 equals 24, so both 3 and 8 are factors of 24. Are there any others? One of the most efficient ways of finding the greatest common factor is by listing the factors with a T-chart. We list the factors for 24 and then list the factors for 12 in a T-chart and make our comparison. For 24, we found 1 and 24, 2 and 12, 3 and 8, and the last one 4 and 6. When finding factor pairs, it's a good strategy to begin with 1, as every number has 1 as a factor. So for 12, 1 and 12, 2 and 6, 3 and 4. When we look at both charts, 1 is a common factor, so is 2, 3, 4, 6, and 12. 12 is the greatest common factor for 24 and 12. Although using arrays to find factors is helpful, 6th graders can use their knowledge of multiplication facts to systematically work to find the factors of each number. Let's try this when finding the greatest common factor for 15 and 35. Let's start by drawing a T-chart for 15 and 1 for 35. When finding the factors, it's good to start with 1 and work systematically up. 1 and 15 are factors of 15. How about 2? Is there another whole number I can multiply by 2 to get 15? No, the next number in counting order is 3. Yes, 3 times 5 is 15, so 3 and 5 are factors of 15. The next number in sequence is 4, but there isn't any whole number times 4 that equals 15. And since 5 is already listed as a factor, then we know we have found all of the factors. Now let's find the factors for 35. Again, let's start with 1. 1 and 35 are factors. How about 2? 2 is not a factor of 35 because it is not divisible by 2. How about 3? No, because 3 times 11 is 33 and 3 times 12 is 36. What about 4? Since 2 is not a factor of 35, then 4 will not be either. How about 5? 5 times 7 equals 35, so 5 and 7 are factors. Is 6 a factor? Again, since 2 is not a factor, then 6 will not be either. It looks like we have all the factors for 35. Now let's compare both charts. 1 is common and 5 is common. Which is greatest? 5 is the greatest common factor of 15 and 35. Let's try one more. What is the greatest common factor for 18 and 11? Starting with 1, 1 and 18 are factors. 2 and 9 are factors. 3 and 6 are factors. How about 4? 4 times 4 is 16, and 4 times 5 is 20, so no, 4 is not a factor. How about 5? No, because 18 doesn't end in 5 or 0, so we have found all the factors. Now let's find the factors for 11. Let's start with 1. 1 and 11 are factors. How about 2? No, because it isn't an even number. How about 3? No, because 3 times 3 is 9 and 3 times 4 is 12. How about 4? No, because 2 is not a factor. Wait, 11 is a prime number, and prime numbers only have 2 factors, 1 and the number itself. So the only factors for 11 are 1 and 11. Comparing both charts, 1 is a common factor, but that's all. So in this case, the greatest common factor for 11 and 18 is 1. The objective of this lesson was to identify the greatest common factor of two given numbers in the range of 1 to 100. We accomplished this by using rectangular arrays and T-charts to organize and compare the factors.